I'm going to do the training on blockchain. The steps are going to be an introduction to hyperledger fabric network. I think all of us are familiarized with it. The second one is the smart contract employed on ARCADIAN-IoT. Later, we will see the service deployed and the test, and we will perform a test demo. And after that, we will have the training session on deploying the hyperledger fabric network. So, what is hyperledger fabric? It's an open source blockchain framework designed for building a quality-grade enterprise blockchain networks. Why we should use it is the main reason is we got a high performance and with a great efficiency, and also for the following key features. It has a permissioned network, which is suitable for enterprises with high privacy and security requirements. It has a modular architecture, so that means that we can add components as our to complete our when they are needed. For example, you can add an organization if this is needed. You can remove an organization, add a new channel, deploy a new smart contract, and so on. The smart contracts are the business logic of the blockchain application. It has a scalability and performance. As I told you, it has a high efficiency, so it doesn't have any problem with high volume transactions. And with private channels, you can ensure privacy and confidentiality between organizations. You can establish a private collection, so two organizations or more can have a private communication with others. Organization doesn't knowing what the other parts are doing. We got a graphic on the hyperledger fabric efficiency. As you can see, hyperledger fabric is over there. It has a proof of authority consensus, so it doesn't have any kind of solving cryptographic problems like in other blockchain networks, such as Bitcoin and Ethereum are the top one on the road. It has proof of work, which is high power consuming. And here we have the comparison of CPU for different loads. Hyperledger fabric is something inside. Here are, for example, 5 transactions, 50 transactions, and 2,000 transactions. You can see it didn't even take a lot of CPU, so it is pretty efficient. And this is the fabric architecture. This is the most important is the orderer, which is responsible on maintaining the ledger and ordering the transactions to the channel. Then the transactions are executed by the peers. The peers execute the transactions with the smart contract that is deployed over there, and this is the ledger. This is the chain code that every of that organization have approved. And then the applications connect to the channel, and the channel connect to the peers on the chain code. And this is the certificate authorities that are the responsible of issuing the certificates for every peer and organization. Then we are going to see the smart contract deployed. Is written in JavaScript, and it has the following transactions. Create reputations, which creates a new asset with a specific reputation ID and collection. We will see later what a collection is and the data object. The next one is read reputation, which is the actual read from the blockchain with the reputation ID and collection. Then you have the update reputation, which updates the private asset with the specified reputation ID and data object. And the delete reputation. The most important part of a blockchain is to purge private data so it didn't appear on block or logs. The block is a history of the transactions. And here we have the most important part of the chain code deployed, which is the collection file. This file is a JSON file that defines the collections for hyperledger fabric. A collection establishes rules between two or more organizations, so we can establish a private communication between that organizations. We got, in this case, two collections, one for the reputation, which is member-only read and write access for reputation objects, and we have also an ABI collection. It is the same, but for the ABI objects. And we can see the public state in the case of our chain code is empty, and the private part of that asset is on every collection, and we store the AOT ID and the data object. We will see later a test, so all we can see what is storing on the blockchain and what is it isn't. And this is a schema for the collection we will see now. This is the collection JSON. As we can see, we have two objects, the reputation and the ABI collections. On the poly side, you put the members that are going to communicate. In the case we have, for example, more organization, you put there or 3 or 4 or 5, and then they can communicate. The max peer count means the maximum, the peers. Block to live is if the information is if the private information is gonna live in more than one block. In this case, it's set to 0 because we need a high privacy. Member only read it is as the name says, and member only write the same. And the signature policy is the same as the policy at all. So in this case, if you want a more graphical view, it's like we got to the collection file represents data state. This is an example that I got from online. It doesn't have the public state will be empty, and the private state will be this one. So we have two organizations that communicates with these ones. And for example, the organization 3 can access to that states. Next one are the service deployed and the test demo. The service deployed is a JavaScript REST API that interacts with the smart contract that we have seen, and we got the same transactions that we got on the gateway. So this is very simple. Get collection that retrieves the data object, delete to delete the data object, post to create a data object, and put to update the data object. The interesting part will be the testing. So we will perform a little test on the publisher smart contract. As you can see here, we got the Swagger for the smart contract. Then we're going to perform a simple test. We're going to obtain the a missing object. I will change actors because we are now evident. And for testing purposes, I'm going to shorten this. Then I will perform a get to a non-existent object, so it will give us an error. And as we see here, I don't know if you can, everyone read it, but we got a message from the blockchain, chain code response, the asset reputation evident net 1i does not exist. So we are going to make them exist on the blockchain. We will perform a post. Then I change here for evident, here for 1a. Okay, then we are going to create a new object on blockchain called evident.net 1a with the object type reputation on the collection reputation with the score 1, source ARCADIAN-IoT, and some random date. I will perform that. Now we got the response that the asset has been created. And then if I go top and execute get, it will say that the following object is this one. As I told you at first, we got two collections. Then if I change here the collection for RBT, it isn't going to be on that collection. So it has to tell us that the asset doesn't exist. And as you can see, the asset reputation evident does not exist on that collection. So the following is updated. I will update it with some other random values. For example, this is this is 1a, and I will change the score instead of 1 to 13. I will execute it. The asset has been updated, and you can also test it for integration with I will post the URL so you can use your curl calls for integration purposes. And yeah, it has been updated. And if I read now the asset again, as you can see, a score which has which was 1 on the later now is 13. And the next transaction is delete. I will perform a delete transaction. Here evident. If I execute it, it says the asset has been deleted successfully. We will see if it is deleted or not. And we obtain the following error. The reputation asset does not exist. So it has been deleted completely. I go back to the presentation. Yeah, we perform the create and read with one collection, update and verify the things are done, and delete and verify this has been deleted. The presentation, we will post the presentation later, so you can log into the Swagger URL if you need it for testing purposes or integration. It has temporarily an IP address. We will put later an actual URL address, but for the time it will be with that IP address. And now we got the most important part of this presentation, the per-layer fabric deployment. These are the system requirements. We are going to use the per-layer fabric 2.5. The network topology will be multi-organization. with 3 organizations. The prerequisites of the systems are you need Docker, Node.js on public samples. You also need the cryptographic materials. We will see how to create that cryptographic materials and configure the network parameters. This is the network's infrastructure. You got a channel. These are the peers. This is the smart contract, the ledger, so every tag. And yeah, this one is the obtain ledger. So for this example, we are going to use Docker Farm to make it easier. This is the first part to create a Docker Farm. One host has to be make the swarm init, and the other one has to perform with the output from Docker Swarm token. We give you a token so you can join in the host 2 and host 3, and then you have to create an overlay to establish the connection between the 3 hosts. Then you have to perform, to check everything is correct, you have to perform a Docker network ls, and then you will see that there is a first network on every host. Then the most important part is the configuration part. I'm going to show you these 3 YAMLs to see how they are. The first one is the config tx. This is for this part is a bit high level. It's a high level definition. So here you define the organizations. Each organization has to follow. We will post these configuration files later. So don't think you're lost because it's pretty straightforward. You just have to copy them and use them. These are the policies for each organization. The capabilities, the applications. This is very important to put the channel defaults and the profiles for the organizations. Here you have where the certificates are located. Address of each host. The next one is the crypto-config file. The crypto-config is the responsible of generating the cryptographic material for each organization. In this case, we got the first organization here, explaining a bit, and the other one without comments. We will post them later. And for each host, you need also a YAML configuration file. In this case, we need the following volumes, as we have seen on the hyperledger fabric network architecture. We need orderers, the peers, and the CouchDB are for storing the information. And there is also one volume need, that is the command line interface. This command line interface will be common for the network. And in order to log to this command line interface, you need the certificates created before. So you can log to that command line interface as the organization 1, as the organization 2, or as the organization 3. But the command line interface, it is only deployed on one host. Then I've seen the configuration files. Yep. The config for setting up the 3 organizations, the crypto config for generating a directory for the cryptography, and the host and YAML with the following services: peer, order, and coach3, and the one with the command line interface. To generate the crypto config material, you have to execute the following commands. And the first one, read the YAML. The next one is for the network. And the next one is for the channel. And then for every peer, you have to configure the output and source peers update. You can see OR1, OR2, and OR3 on the channel created before, the network. Then we have created the cryptographic material, and then we are going to execute a Docker Compose app, in this case for the host 1. In the case for the host 2, it was Docker Compose, and instead of host 1, put host 2.yaml, and so on. Then with in the host that has the command line interface, we have to execute docker exec command line peer channel create. The following commands are for identifying the organization, in this case the order and the channel. This is the channel name. Then we got the cryptographic path to identify as organization 1. The rest of the hosts have to execute docker exec peer x for every, in the case of peer2, peer2.org1, example.com, peer channel, get info my channel. And then this is not get info with, it's join channel. I put get info, but it's wrong. It's join channel. I will change it later when I upload the presentation. And to check to see if every host have joined to the channel, we have to execute the get info, and it's pretty important to check if the head is the same, the current block hash is the same, and the previous block hash is the same, because it could be desynchronized. For example, it could say the current block hash is the previous, and the previous is a past one. So it's pretty important to check everything is right before continuing the next step. And then we have to package and install the chain code. The chain code at first is on source code, so you will have to package it in order to install it. To simplify, I use environment variables, so it has a more readable command. Docker exec command line interface peer lifecycle chain code package. The lang in this case is Node, because the smart contract is written in JavaScript, and the label is the identifier of the current chain code deployed. After it has been packaged, you need to install it with the following command: chain code install, st name, Then it will create a new volume, so you can check with Docker PS if the new chain code associated on the container. Then after the installation, you need to approve the chain code. So we can, in order to use a chain code, to avoid people putting malicious chain code, every organization has to approve the chain code in order to use it. So the chain code that we are using is trusted by every organization. You have to get the package ID, which is an unique identifier with the following command. And with that identifier, that will be stored on environment variable. This is the result of that command over there. And the command is straightforward, approve for my org. In this case, I highlighted this part of the command. This one is where is located the cryptographic material, because as I told you, the command line interface is common, and you need to identify yourself with your current certificates. So the command line knows you are identified as one organization or the other. In this case, you have to approve your chain code for your organization. So this step needs to be performed for every organization that is deploying the chain code. In this case, this is for the first organization. The second organization will perform this same command, but with his own certificates. And then you can check the approval status. If everything went right and every organization has approved the chain code, it will appear that every organization has approved the chain code. I will perform later a demo. I know this is pretty intense in commands, but we will see later a graphical view. Then we have to commit the chain code. When every organization has approved the chain code, then we are going to commit it in the channel so we can use it. In this case, I simplified the command even more. As I told you, the flag CI file means that the following are going to be the certificates file. This part is the files for the organization 2. These ones are for the organization 1. So I am going to commit the chain code on every organization in one command. And then you have to check if the chain code is committed. With query committed with the following channel and the smart contract name. And this is a graphical view of the steps that I have told you. On the first one, these are the part where you only got the cryptographic material, the chain code without it being committed, and the configuration files for the order. In this step is the part where I made the Docker Compose app. With the Docker Compose app, you are on this stage. As you can see, the orderer and the peers are connected, but we are missing the part where the chain code is committed. Okay, there is no chain code on the peer installed, just the connection between the channel. And on this one is where we perform the approved and commitment to the channel. So now the peers can execute the chain code and evaluate with the ledger. And on the next step that is not part of the deployment, but is part of the Arcadian IoT, is connecting the applications to the channel through the gateway. And then I'm going to perform, to emphasize again on the timecode lifecycle. I am going to perform a little demo on test network. As you can see how it works on the test network. To simplify, I execute a test network because the process of bringing up a free host and everything is pretty time consuming. So to simplify it, I will use it on the test network. The first is to refresh the environment variables. Now I'm going to okay. Then the next step is I'm going to get inside the test network path. I will export the peer paths. Okay, I'm going to check if I did it correct. Then, as I told you, we will perform. We will package the timecode as we saw on the first step. It doesn't say anything, so it has been packaged successfully. Okay. Then I'm going to I'm going to package it again because it has a similar name as before. Sorry. One second. I'm going to change the name of it. Oh. Okay, I perform the package, then I'm going to perform the install. Cannot run a peer. Yeah, I have to identify as a peer. This is as I told you, you need the TLS and the MSP, which is the responsible of managing the authentication and authorizations, and the TLS is the file that is stored from the certificate authorities. And after identifying as organization one, then I can install the chain code. Yeah, as you can see, this will be similar in your machines. And this is installed remotely, chaincode package identifier, publisher. So that means that the chaincode has been installed successfully. Now I have to install it as organization 2 also. So I will put myself as organization 2, modifying that environment variables, and execute again the install. Yeah, it has been right now. Yeah, it has been installed. Now I am going to query if it is installed to obtain the package identifier, but the package identifier is over there. But in case you need it, it hasn't worked. Wait. Then, as I told you, we need to perform. We need to approve the chain code installed as every organization. So this will be as organization 2. This command will be as if organization 2 approves the chain code. And it has a committed status valid. So it has been approved. Now I have approved it as organization 1, so I will change my credentials to work as organization 1. And I will perform the Yep, it has been approved. And now if I check commit readiness, it says the following approvals: organization 1 and organization 2 has approved the chain code. And now we have to commit the chain code to the channel. So in this case, we are right now at this step. And the next step, when we commit the chain code, that means that the peers is going to be able to use the chain code. S5 is the chain code installed. So if I execute it, no, it has been executed. In this case, I have executed it as peer 0 organization 1, and I have also identified with the TLS root share files as organization 2. So I execute the command like on the command line interface deployed on host 1. And now we can also test it. I don't know if this will work because it's an old version, but we will try. I will try to write on the new smart contract. No, it has an error. It has this is an old version of the asset, and I'm not going to be able to test it right now. But the steps are that you have to commit the chain code in order to use it. And after that, we got solving issues. Most common issues are solved by logging on the containers. Sure. I can show you to what will be the containers deployed. And as you can see, we got this is the peer on organization 1. This is the peer on organization 2. This is the publisher gateway application. This is the publisher smart contract, and this is the other smart contract that we have deployed. So to solve the most common issues, you will have to enable login on the peer container. Is where the most common issues are located. You can follow the link to read how to enable it on the interlayer documentation. And there is also errors in chain code. I don't think there will be anything because this is more related to chain code development more than deployment. But this is like enabling a debug for chain code. You can actually debug in a traditional way a chain code because it is working on the blockchain and not on your computer. So with this, with this logspot, you can debug the chain code on blockchain. That's it. I don't know if we got more questions.